lot of people still think airplane toilets work in the simplest way possible. You press a button and everything just disappears into the sky. Sounds logical, right? You're thousands of meters up in the air. Where else would it go? But if that were actually true, living under flight paths would be a very different experience. And from a safety and environmental standpoint, it would make absolutely no sense. In reality, an aircraft toilet isn't just a hole to the outside. It's a fully engineered system with valves, tanks, sensors, and pressure control. But it didn't start that way. To understand how we got here, we need to go back to the very beginning. In early aviation, comfort wasn't really a priority. Aircraft were small, flights were short, and toilets simply didn't exist. If you needed to go, you waited. As air travel evolved, though, that quickly became a problem. Flights got longer, more passengers came on board, and just hold it stopped being a realistic option. So the first solutions started to appear, and they were about as basic as you can imagine. Buckets. Yes, literally buckets. From an engineering perspective, that's about as simple as it gets. But in terms of hygiene and safety, not great. Turbulence, tight spaces, human error, all of that made these early setups unreliable and, honestly, pretty unpleasant. It became clear, if aviation was going to scale, it needed a proper built-in system. One of the first real engineering solutions was the gravity-based toilet. The idea was surprisingly simple and kind of clever. The toilet was connected directly to a valve in the aircraft's fuselage. You pull a lever, the valve opens, and everything is released outside, straight into the airflow. No pumps, no complex systems, just gravity and airflow doing the job. Engineers liked it because it was lightweight and mechanically simple. Fewer parts meant fewer things that could fail. Passengers didn't mind either. Airflow carried odors away almost instantly. But this simplicity came with a serious downside. First, the system wasn't fully controlled. Not everything was removed cleanly, and odors could still be an issue. Then came more advanced designs that used water for flushing, which introduced a new problem: weight. In aviation, weight is everything. Every extra kilogram means more fuel burned. So the more water you carry, the more expensive the flight becomes. On top of that, systems with storage tanks brought another challenge: capacity. If the tank filled up, the toilet simply stopped working, and on long flights, that could happen before landing. Now imagine that scenario mid-flight. Add to that leaks, sealing issues, and maintenance complexity, and it was clear the system still wasn't good enough. And then came one of the strangest problems in aviation history. To control odor and bacteria, aircraft started using a special chemical fluid, the well-known blue juice. It disinfected, reduced smells, and helped break down waste. But early systems weren't perfect. If there was even a small leak, that fluid, along with the waste, could escape to the outside of the aircraft. And at cruising altitude, where temperatures can drop to around -50 degrees Celsius, it freezes instantly. That's how something called blue ice was formed. Frozen waste mixed with that blue chemical fluid. In some cases, it would build up on the aircraft's exterior and later break off during descent. Yes, there have been real incidents where these frozen chunks fell to the ground, sometimes onto houses, sometimes near cars. Rare, but very real. And stories like that made one thing clear: this wasn't something you could just improve. The entire system needed to be rethought, and that solution was just around the corner.